Hi, so it seems my AIXUN, or I'm not sure how you pronounce it, but it's spelled AIXUN, soldering station seems to have given up the ghost. So, we'll see if we can repair it. I shall just apply some power. We'll just check that we've got power on this mains lead first. And we have 251 volts, nearly 252. So we shall apply some power, switch it on, and not up. This actually seems to be working now, but it wasn't working the other day. Typical, isn't it? Switch it on and it's working now. Oh, there we go. It's switched on now, but we have nothing on the display. And that's what it was doing the other day. Just wasn't coming on like that. So I've got a feeling... Oh, have we got a dry joint in there somewhere perhaps, or capacitor on a power supply maybe? No, it just seems to have a bit of a reboot loop thing going on. Well, there's definitely some kind of problem in there. So I think we need to take it apart and have a look and see if we can figure out what the problem is. So I'm going to disconnect the iron part from it and we'll put that to one side. And we'll have a look at the control module. Right. So we seem to have 4 screws on the back. So I'm going to start there. It actually seems quite well made. This, you know, the quality of it actually seems okay on the external case. Anyway, I'm not too sure on the electronics on the inside, but we shall soon find out. Also, a big shout out to the channel My Mate Vince, who kindly gave my channel a shout out a week or so ago, and thank you very much for that, Vince. Much appreciated. If you haven't seen Vince's channel, check it out. I'll leave a link in the just about here somewhere. Right, so I can see a power supply in there. Looks like it's held in with this small screw. So we'll remove that. Now we'll have to be careful that there's no charged capacitors in here. Now I can see a power connector. I'm not sure if that's showing up on the camera there, but there's a power connector just down the bottom there. So we'll see if we can release that somehow. Oh, it's actually just popped off when I've just give it a little tug on it there. So, right. I mean, none of these capacitors look bulged or anything, but then again, none of them look bulged on that Bose radio I've just recently looked at. Looks like they've ground some numbers off on the power supply there. That seems a bit strange. I don't know why they've done that. We have some tape over the bottom of it, so we can't quite see. Actually, that's on the output side. I was thinking those the mains going in, but they're soldered to the output of the power supply, and it goes to a power jack at the back here, which is marked 24 volts at 8 amp. Now I'm going to proceed with caution here because there's a large electrolytic cap there, which is across I just charged up from the mains, so let's get that sticker out of the way and we'll just see if there's any voltage in that cap. Yeah, there's not a lot, about 18 volts in there. So that's pretty safe now anyway. But it doesn't look like there's much of a bleed resistor on there due to the fact it's still actually got voltage in it. Now, I don't know whether there'll be a problem in this part of it or whether it's the power supply. It's a bit hard to see in there. If I just tilt it a bit, maybe to get a bit of a better view in there. Looks like we've got a MOSFET just on where the power comes in there at the left, which looks like it goes straight to the soldering iron port, which is like the 5 pins on the bottom left there. What else can we see? Looks like there's a little power supply just above that MOSFET, about where the earth wire is just going across the circuit board there at the left hand side. I guess that's for the powering of the microcontroller, which is over on the right hand side next to the USB port, which apparently is for updating the firmware. So it doesn't seem to be a lot in the front panel. I'm just wondering if there's some kind of ripple or something on this power supply. I mean, it could be a dry joint on the power connector even, but we'll have to try and get that board out. And I think you've got to heat this front screen up with a hairdryer or something, get a pry tool under it, and then that pops off, and I think there's 4 screws under here. I've seen somebody taking one apart, like a teardown video on one of these, and apparently that's the way to do it. So what do we do? Well, I might just measure the voltage on the output of this for a start, just to check that we have 24 volts. Right. I just put my probes in here. Yeah, I actually snapped one of the probes off. I had to put had to solder it back on. That's why it's a bit worse condition there. Check that's off. I'll put this in, and then we'll switch it on, and we'll see what voltage we get. And we'll get 24.06, which looks about right. I mean, I don't know if there's any ripple or anything on there. I'd have to check that with the scope. And I don't know whether, because we haven't got any load on it, any fault on the power supply mightn't actually show up unless you've got actually a load on the power supply. What can we do here then? Alright, just give me a moment and I'll have a quick think about that. So I thought I'd hook it up to the scope. There is a slight little bit of ripple on there, but not a huge amount. Right, so I don't think the problem's in the power supply, so I think we're going to have to take this front panel off. So I'm just going to undo this earth wire, and we'll get the power supply out of the way. Let's put that nut back on so we don't lose it. And I think I'll stick this bit of tape back over. Something that's a bit further over, because remember it's got to slide into the it's got to slide into the enclosure, hasn't it? Right, so something like that. Let's put this out of the way. We'll use one of these spudgers, hopefully. I think that's the correct name for them. And I'm going to use the rework station just to hopefully soften the glue on this. So I've got it set to about 120 degrees, and hopefully we don't melt the plastic. It's actually got a quite nice display on this as well. It's nice and clear. It's actually not a bad little unit. Like I say, it's quite well built, but it's not even that old. I've only had the thing about maybe 4 or 5 months. So I don't know whether other people have had problems with these or not. If you know of, or if you've had problems with one, leave it in the comments below. Right, we'll try that. This is actually glass. I don't know if this is actually glass on here. Have I got a suction cup? I do, but it's not the best. Yeah, this suction cup's a bit rubbish. It came with a tool set that I had. Right, I'll see if I can find some other way of getting it off. One moment, please. Right, so after a bit of persuasion, the front panel is off. And yeah, it is glass. I thought it was plastic, but yeah, it's got a slight chip on the inside now, but well, not the end of the world. At least I didn't break it. Right, so let's see how this bit comes out. If I can find my smaller screwdriver. There we go. And hopefully we'll be able to see what the problem is. Right, so there's not a lot on the front side of the board. It's pretty much just the screen and the buttons, and all of the electronics are on the back of it. And this is a version 1.2. Right, I think I might bring the microscope in. We'll see if we can see anything obvious on the board. Right, so the power comes in here. It looks like it goes underneath this MOSFET. Let's see if I can get that in focus a bit better. That's a bit better. Right. So the power comes in here, and it looks like it goes underneath this MOSFET, and then through here. This MOSFET here is what controls the iron to switch on and off. That's the gate of the MOSFET here, which then goes up this track and then along and ends up at this transistor here, and then goes off to the microcontroller via that wire. So that's how it actually switches the soldering iron on and off to regulate its temperature. This looks like a small power supply here. It looks like we've got probably a buck converter IC here. We've got an inductor, which then looks like it goes to this capacitor here, and then it looks like that goes off to the microcontroller. It seems to go through a couple of wires here, and then you can't actually see where it goes to. So what else? Let's have a look at the microcontroller. So the microcontroller is a GD32F305, and it's got Giga device on it. So I'm not sure what that is. GD, yeah, so Giga device must be the GD part of this. So it's a 32F305. It looks like it's an ARM processor. What we've got down here, there's a little 0 ohm resistor there, which seems to go to that pin there. I'm not sure what that's for. Wouldn't have been there. It could just be used as a jumper, but a lot of times they just use like a fusible type of resistor. What have we got here? This looks like a kind of debug UART. What we've got here is ground, and then TX and RX pins by the look of it for communication, and a power pin there. So it'll be like supply voltage. And it looks like we've got a pull-up resistor here, because that's wired to the supply, which then goes to that pin there, and a pull-down resistor, because that one obviously goes to ground and then to that pin here. Well, I can't see any dry joints or anything on this. We've got a little LED here. I'm not sure what that's for. That looks like a little LED. I think those run off to where the irons actually plugs in. The pins of which are mirrored on this header connector here. So we've got plus, minus, ID. I'm not sure what T and S is. T probably temperature sensor. I'm not sure about S. These run off over in that direction. So yeah, I think that's about it. Right, I think what we'll do now is we'll plug it back into the power supply and we'll measure some voltages just to see if we can figure out what's going on. Right, so I'll switch it on. And we've got the power supply lit up there. And I know this header should be power, so let's see what we've got on those pins. And we've only got 0.8 of a volt. Oh, and this just came, well, that was interesting. It just suddenly sprung to life by itself there. The voltage shot up to about 2.4, and now it's dropped back down to about 0.8. So I would say the problem's around about here somewhere. I was just pressing some of these components in case there was a dry joint or anything, but it doesn't appear to me making a lot of difference. That was weird how it just suddenly sprung into life and then went off again. Well, yeah, we've only got 0.8 of a volt there. Well, it doesn't appear to be a dry joint. I'll just try switching it off and back on again, see if that makes any difference. Well, at least we know the area that the problem seems to be in. Still 0.8. I'll just double check the supply voltage coming in here. 24. Where's the input to this boost circuit? I know we've got no output, but have we got any input into it? We've got 23 volts there. Nothing on that side of that cap. I don't know what that diode's for. I wonder if I can find some information out on that chip. Like I say, there's a small, like I said, I think it's a buck converter chip there, which will be taking the 24 volts in and dropping it down to 2.4 or 3 volts or whatever. And that doesn't appear to be happening. So I thought I'd try and get a bit closer look at this IC here, and that seems to be the number on it, 1ALLN. Now I can't seem to find any information on this IC at all on the internet, but I might just run over it with the iron just in case there's any dry joints on there. Right, I'm going to put some flux on there, I think. Right, just get a little bit of solder on the iron here. I'm just going to carefully go across these pins. And the bottom ones. Right, I think we'll see if I'll give that a quick clean up, and we'll see if that's made any difference. Swing this out of the way, and we'll give this a try, see what it does. So when I moved it there, I could hear a I wonder if it's these connections. I've definitely heard like a crackling. Yeah, there. I don't know if you can hear, I don't know if that's picking up on the microphone. There. I wonder if it's a bad connection in these. Obviously it's not helping. To rule it out, I think I might disconnect this, do away with this plug and just solder two thick wires from there to there, and we'll see if that sorts the problem. Right, so I've tinned up a couple of bits of wire there, and I'll solder these on and we'll see if it makes any difference. And then we're doing away with those connectors just in case it's something to do with that. I don't think it is, but like I said, it was definitely making a bit of a sparking noise when I was moving them, so we'll just rule it out. That's about the only thing I've found so far that's something of sort of semi-fault in any way, if you know what I mean. Right, which way does this go then? Right, so negative to the top. I'll just double check if I put it on that way around. Right, negative to the top. Right, now before I switch this on, I'm just going to double check with the meter. because I don't want to really blow it up. So that's a positive, that comes through the MOSFET. Just put in beep. That's a ground, so yeah, that's definitely ground, and that goes to the ground there. Right, let's see if that does anything. Well, it went beep, it came on, and it's gone back off again. Let's double check if we're getting any voltage on that voltage regulator again, or on the output of the chip, or the input of the chip rather. 0.89 again. Well, at least we've ruled out that connector. I'm sort of leaning something towards this voltage regulator circuit. I wonder if that IC could have gone faulty or something. And what we're measuring is just the just what's going through the inductor. It's like that chip's not oscillating. So I thought I'd just try something. I've got my little voltage injection thing here, and I thought I'd just inject 3 volts just onto the pin of the IC there, and it comes straight on. So that proves the problem is with this little power supply here, or definitely in this area. So I've been looking on the internet to see if I can find any information on this chip here, because I was fairly sure that that chip was at fault. So I started trying to work out the pinouts of what does what. So the 24 volt supply comes in on this pin here. The next pin along is the output, it goes under the chip to the inductor here, and this pin here is the ground. I'm not sure what this pin does here. I think it's some kind of strapping pin or something. This pin goes through a capacitor to the inductor, so that's some kind of feedback. That one just goes to ground through a little capacitor there. I'm not sure what that one's for. This one seems to be monitoring the voltage of the output, because it goes through a couple of resistors here, through like a resistor kind of divider, and ends up on this pin here. Now I noticed this diode here, which I think that might be a Zener, because it seems to go through a resistor. Sorry, the supply comes from here, goes through this resistor, and then to this diode, which I think is a Zener, and then it goes from here to this pad over here. So whether or not that's some kind of power supply for this chip to run. So I thought I'll just get the iron and I'll just touch up this this diode just on the off chance, because like I said, I was fairly convinced this chip had failed, and it just seems to have sprung to life since I've done that. So I'll just pull the microscope out the way. And like I say, I've just touched this resistor up with the soldering iron. Sorry, this diode up with the soldering iron, and it seems to come on. Even though it didn't actually look like there was any dry joints or anything on it, so I don't know whether there was a problem in that diode, because when I looked back at the footage on the microscope, if you look back at the footage on the microscope there, when I first look at it, it seems like there's a bit sort of sticking out, like it's not quite soldered on properly or something. But so I'll switch it off. So wait for the power light to go off and the capacitors to discharge. Switch it back on. So it seems to be working now. So I think what we'll do is we'll reassemble and we'll test, and hopefully that's it all fixed. Now just put the glass back on. apart from it's stuck to me wires here, so shame about that little chip in the corner there, but it is what it is. Right, so I'll slide the power supply back in. That goes on the back of this, doesn't it? Tell you what, I'll put this bit on first. I forgot about that one. Right, slide the power supply back in. There should be a screw to hold that earth wire. Hopefully it still comes on. Yes. Right, we'll plug that iron in and we'll double check that iron works. The thing I like about this soldering iron is I keep forgetting to switch the An AIXUN off. And this one automatically switches off when you put it back in its holder, so it's quite good for that. Right, 15 degrees when I pull it out. Heating, yes. So, just checking melt some solder. Yeah. Cool, or hot. Right then, I think that's it. Oh, I'm glad about that, glad I got this working again. Right, so there we have it, fixing a AIXUN soldering iron station. Well, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comments section below. And as always, have a great day. Thanks for watching.